multiplied by 10 squared root of 4. If I increase my confidence, this will be higher. The range becomes wider. If I want to go to 99%, this becomes bigger. The range becomes wider. So you can see the trade-off there, right? The trade-off is more precise, less confident, more precise. Right? More confident, less precise. That's the stroke here. Right? What's the range here? Give me the range. Give me the up and down, then I'll figure out the range. What is the margin of error of this estimation? What is this one? $150 plus minus. You're 95% confident that you fall within that range. What is the up and down? 4, 5? Somewhere there. How much? 3.16. 3.16? 3.16. I want to use this range to do a hypothesis test. That's the intention. The confidence interval was covered in B11, but we want to use it to do hypothesis test. That's sort of the intention. But before going there, what does it mean here? If you want to put this in words, how do you put it in words? The range, say, becomes this one. That's the range for the population mean. That's 95%. That's 153.16. What's the lower end of it? 146, I guess, 84. That's what it is, right? That's the confidence interval for the population mean. In words, what does it mean? You want to put it in words. What does it mean? I know you say, what?
The probability that the mean is between.
You basically say I'm 95% confident the population mean falls within the range. Make sense? So my counter question is this. The population mean is not a random number. It's not like X bar. X bar is a random number. Every sample gives you a different X bar. Make sense? Mu is just one number. Not random at all. You don't know it. It doesn't make it random. So how do you assign a probability to something that is not random? Alright, that's the question. Mu is not a random number. You shouldn't assign a probability to a non-random number. It's just a number. 2, 3, 4, 10, 100, whatever it is, we don't know it. But it's one number, and one number is not probabilistic. You shouldn't assign probability to it. How do you answer that question? The answer is the probabilistic nature of the answer goes to the X bar, not to mu. It runs to mu at the end. Here's what you're saying. You're saying if I get 100 samples, each sample gives me a different mean. I get different sample mean. I'll end up with 100 different ranges. Make sense? 95% of those ranges will include the population mean. 5% are off, or they are very low, such that the range provided is not including the population mean. That's what you're saying. You're saying, I'm confident in my sampling. I'm confident I got one of the good samples that the range provided by it include the population mean. So technically, your probability is assigned to your sampling, not to mu. At the end, I know you say I'm 95% confident population mean fall within the range, but your confidence comes from your confidence in your sample. If it made sense, perfect. If it didn't, that's fine. That is B11 stuff, right? But statistically speaking, you shouldn't directly assign the probability to mu because it's not probabilistic. You're not doing it realistically speaking. You're assigning it to X bar. Have the X bar give me a different range. If I keep doing it, I get different ranges. I'm confident 95% of those ranges include the population mean. Make sense? As a result, I got 1. I think this is one of the 95% ones. That's where the confidence comes from. Make sense? Anyway, if it makes sense, perfect. If it didn't, it's fine too. Let me ask you a question. You got this range. Someone asks you this question. Answer it. What would be your answer? Someone told you, this is the 95% confidence interval. Do this test using it. What would be your answer? Yep.
You would reject them.
Why do you reject?
Because you're using the same alpha since it's 95%. And
Simple rule of thumb, if the alphas are the same, if the test is two-sided, the alpha are the same, the test is not two-sided, then you still can do it, but not complicated. If alpha is the same, and the test is two-sided, check the null inside that won't reject, outside that will reject. Treat the outside as a rejection area. If this falls outside the range you reject, inside you don't. So this 160 falls outside or inside. So that's sort of what it is. You can use confidence interval for hypothesis test. The rule of thumb I give you is only applicable to two-sided test, alphas match. If that's not the case, then you can still use it, but it won't be so straightforward. I'm not going to do it until later. Alright? Okay. What if this was 153.1? What's your answer? You're not going to reject because this fell inside. Alright? This fell inside the range, you should not reject. Simple rule of thumb, inside you reject, sorry, inside you don't reject. That's the 95% area. Outside you reject, that means the 5% area. Treat it that way, and that makes it much easier to work with. Now let me give you a different question. Let me pose it, we think about it. We'll take a break, we do it right after, then we do other questions. This is 90% confidence interval for the population mean. It falls within 20 and 10. Right? This is the confidence interval for the same mean at 95%. I'm making it up, but I want to be consistent. Should this be wider than this or narrower than it? Should this be wider or narrower than this one?
Narrow.
Wider.
More precise,
Less precise. Like
Sorry.
more precise.
more confident,
Less precise.
less precise. So this should be wider, not narrower. This should be wider. I'll make it wider. That's an 8, 22. I made up the numbers, so they're not consistent based on those alphas, right? I made up the numbers, but I made it consistent. More confident, less precise. I'm consistent on that one. This is 99%. That is mu. This should be 25. Again, I make them up, so don't check it because I make it up here. So I gave it 3 confidence intervals. Make sense? Do this test. Find the p-value of this test. Suppose these 3 confidence intervals are given, right? You're asked to do this test, find the p-value for it. Alright? What's the p-value for this test? Start with this one. Does 6 falls inside or outside?
Outside.
Inside. Outside. Outside. This is outside. Outside you reject or not?
Yeah.
You reject. So if you reject at 10%, what would be p-value?
5.
If someone told you reject this test at 10%, what's the p-value? It will be less than
Less
Or
than
less.
10%. That's the conclusion. Since you fall outside your jack, the p-value is less. Make sense? So the conclusion is the p-value is less than 10%. What about the next one? 6 is still outside. You jack at 5%, the p-value is less than 5%. Right? What about the last one? You fall inside, not outside. So you do not reject at 1%, the p-value is more than 1%, that would be the range of p-value. Make sense? So I use a simple rule of thumb. Inside, you don't reject the p-value is more. Outside, you reject the p-value is less. That enables me to range bound the p-value. Make sense? Good question. A version of this one has almost always been on test one. I sort of give you everything. We're linking up the confidence interval and hypothesis test from one side and knowing the relation between whether you reject it or not and p-value. So let me change it and do this on your own, and we'll do it after we come back. This is 4. What would be this one? And then when you do this one as well. So I give you 2 tests, do them. Where are we going to operate? Number 1 is this, number 2 is this. Two hypothesis tests, one testing 4, one testing 11. What's the p-value for these 2 tests? Use the same idea, see if you can range bound the p-value. Make sense? Okay? Okay. Short break.
So how are you doing? I'm good. Good. Chilling. How about you? I'm exhausted. Why? I slept about 2 in the morning. Started for an exam.
Already?
This morning, yeah.
How was it?
Doing well.
What course?
MGEB12.
MGEB12.
Presentations. The problem with the courses is that they end up doing these,
Oh, sure, okay. What were you saying?
they end up doing these presentations that are worth 10 to 15% of your grade. What's your name?
It's you.
With you?
Yeah.
Anas. I am.
Anas?
I am, yeah.
Hey.
Are you from Saudi?
It's not us.
Oh, no. Technically I'm from Pakistan, but I just came from Saudi.
MGEB. Oh, 1 or 10? Oh, psych. Like another question like this. Did you get it? How would you rate your answer in English? Like this was the answer, and I understand how you did the answer. How do you like in English? Like
The p-value, the probability of committing a type 1 error is greater than 1% but less than 5%.
but that's for you equalences or not equalences?
Like whatever the type 1 error is, whatever the, it's like accepting a null or rejecting the null, like whatever the type 1 error represents, because that's what p-value is.
Because it was like u equals 6 or u equals equals 6.
So yeah, so that was a two-sided test. And so he was just saying like the error, the probability of committing a type 1 error, because that's what p-value is. And the p-value represents that.
Yo, do you know how many tests is?
Which one?
Yeah, no, I mean the first quiz.
First, I don't know. I think it's randomized.
Quiz?
Yeah, there's pop quizzes.
Pop quizzes.
You didn't know
I
that?
don't know.
No?
They're different.
Did you not read through it?
No. Really? Fuck, I don't read stories. Is it open book?
Yeah, it's
I
open
think
book.
so,
You can
but-
use your phone. You can do whatever you want. Just don't use ChatGPT. It doesn't help.
Probably not.
I tried using ChatGPT for some of the questions.
Did this quiz before?
I did what was the other
VO2?
one? VO2. VO2. But
That's BO2.
it's
I used to
pricey.
do this.
Oh, that's
But what's it called? In the summer, he did the same thing, like 5 pop quizzes for VO2. And the people that use ChatGPT pretty much got everything wrong because ChatGPT didn't know what they were doing, and they didn't know what ChatGPT was doing.
I still didn't have pop quizzes though.
In the summer, they did.
No, it wasn't pop quiz. It was like schedule.
In the schedule?
It was like after every class.
Then, but it was the same format. It was open book. Use whatever you want. Where do you make your laptop? What is it?
Mine?
Laptop.
The Windows. Windows, like literally Windows.
Oh wow. Okay.
Not like HP, like Windows. It's like the Surface. I can check. Do you really want to know the model?
No.
I'm not.
It just looks cool.
Oh, I'll just check. I'm not sure which one. I mean, it's one of the Windows laptops.
Looks
The Surface laptop Go to.
Oh nice. It's touchscreen. Does it have a pen?
I think you can buy one, but it wasn't like not my alley, not my type of thing. I prefer like I have my iPad already, but I just want this to like type. Like I don't know.
Why would you choose a Windows when you have an iPad?
Because like I like having like a laptop. You know? Like for example, sending emails, I would never do that on my iPad. Just for
No, I mean, why would you buy a Windows? Why not an Apple?
Apple sucks, right? Oh, Apple sucks.
Come on, man. Apple's the best.
Oh, how much was that?
700.
This was 500, and I can either the specs are the same or the specs on this are better. What's the point of spending the extra 200?
The specs on these are way better than yours, bro.
What are the specs? Alright, let's go through it. What are
The specs aren't even in the same league, bro.
okay, let's hear it. What are the specs?
I have an M1 processor. It's better than an
Which
i9.
is like some like Apple stuff. I don't know how that relates. How does that relate?
It's
to
better than an i9.
Better than an i9? Okay, how much RAM?
It was 8 GB. The RAM is low on it. I agree.
It should be. Yeah, 8 GB. I have what'd you say it was M1?
You can't have an M1. M1 is Apple only.
Yeah, I'm trying to benchmark it. So I don't like not have that.
The closest would be i9.
It's an M1 8 core.
Yeah.
Okay, let's see how that benchmarks.
So because Windows is clearing.
It's the 200 fastest.
What?
It's ranked 200 out of CPUs. That's like right, I guess. For laptops. Let's see.
You have an i5, right?
Yeah, but it's 12th generation. Let's see. Let's benchmark that. Like, is Apple on here? Is it on here? It's not even on here. Okay, let's benchmark this. i5.
Is it multi-core or is it single core?
Well, there are some Mac, but I was waiting all together. I don't know why.
How do you even see that?
Because if it's single core, then it's relatively equally matched, but the power efficiency of the
No, it has 4 cores.
Hmm?
Has 4 cores in Bro, the M1 has 4 chords, 4 threads. It's about to be. So like they're just as good. You guys have 22.
So they're basically equally good.
Yeah, but for 200 more dollars. So it's like, why would I get Apple when I could get something cheaper? Like, and then invest in 200. Or just get AirPods. Like that 200. What's the 200 going for? Just so I can have Apple on the back?
It's just a better user
Oh my god, I disagree. It is the most disgusting thing. Like this is so technical. Yours is so like.
That's my problem. I can't do technical. Like it is so like there's so much. It's too much.
I prefer it because it's technical. Just, it's when you want to do easy things on like this technical OS, it's harder. I agree. But when you want to do harder things with the technical OS, it's easier. When you want to do easy things in Apple, you have like all your bars here. You can easily pick one.
I have nothing difficult in my life.
When you want to do a harder thing, that's when it's like using Apple on the app for easy. Like when you coding with the Apple when I was coding in high school.
No, apparently Apple's better at coding.
No. Okay, maybe it's better, but like
I don't code, so I just heard that.
like it's just like for Windows, since like 90% of people who code use Windows, they have like this application, but it doesn't run on Apple. So you have to do this other thing, and then when you watch tutorials, it's not in the same application. So you're like, yeah, what is this?
Do you code?
I used to in high school, not anymore. No point. And just like paying more for that, it's like I would say I'm a Google person.
You could get the M1 MacBook Air.
I'm not kidding, bro. I'm not buying that.
It's the same price.
No. The only thing Apple's good at doing is phones. And even that, probably gonna get an Android.
What phone do you have right now?
14 Pro. Probably just gonna get an Android next. I can't say that. See, I was
outside all three. Outside all three. So the p-value is less than. The lowest one, choose. 1%. That is less than 1%. That's the p-value because it falls outside the 3. Right? That's the first one. The first one, you reject at 10%, if you got it just 10%, that would be less than 12%, that would be less than 1%, and you stop. Right? That's the 4. 11 is more than 10% because you harden your am I right? Yes. 11 within this range. Right? So you're not going to reject at 10%. You stop. The p-value must be more than 10%. Right? So the way I gave the number, it didn't fall between any one of those. So you could not run the p-value. This 4 is outside all. So reject for all, the p-value is less than 1%. That's the best you can say. This is inside all, including this one, the p-value is more than 10%. So unlike the prior one, which I ranked on the p-value here, so not really ranked on. One more than 1%, the other one more than one less than 1%, the other one more than 10%. Right? Okay, that's sort of the setup. I'm leaving the last topic. I put it in red because this is actually lecture number 3. When I get to a question from it, I'll go to some extent with it, a bit. The reason is because I want the next lecture to be mostly on beta calculation. That takes a bit of time, so I want something from lecture number 2 covered here. When I get to it, I will explain part of that, which is the application to proportion. Okay, let's start with some questions. Question 1. If there is sufficient evidence to reject the null at 20%, at 2%, then there is not sufficient evidence to reject the null at 3%. Sorry, if there is non-sufficient evidence, reject the null at 2%. At what alpha you cannot reject either? That's the question. If someone told you you're not going to reject at 2%, give me an alpha that you're confident you're not going to reject at that as well.
Anything less than 2%.
Yes. If you do not reject at 2%, the p-value will be more than 2%. So you're not going to reject at anything less than 2%, right? That means anything more than 2%, less than 2%, you're not going to reject. That's the answer. Because if you do not reject at 2%, the p-value will be more than 2%. That's the conclusion. Since the p-value is more than 2%, you're not going to reject at anything less than 2%. Right? You're not going to reject at 1%, 0.5%, anything lower. Anything more, you don't know. Anything more than 2%, you don't know because you don't know the exact p-value. So, simple rule of thumb. If you do not reject at an alpha, you're not going to reject at anything less. Anything more you don't know. Right? If you do not reject an alpha, you're not going to reject at anything less. Anything more, you cannot answer. Make sense? Okay. That is the first one. The second one, whether to use a one-sided or two-sided task, it depends on what. What tells you whether you should use one-sided task, two-sided task, upper tail, lower tail? What the primary reason? What is the primary cause of setting up the hypothesis the way you set it up? The answer is, well, the theory. Whether the test is upper tail, lower tail, two-sided, depends on what you want to test. All right? I give it tricks. The null always have equal sign, the alternative doesn't. All this stuff, right? But the main reason you set up that way you set it is because of the theory. The theory tells you whether you're testing more, less, not equal. That's the theory. All right? Makes sense? The primary reason the test is set the way it's set is the theory. The rest are just tricks I give you a benchmark. So when I said that no, you always have equal sign, that gives you an idea how to figure it out from the question. But whoever put the question had a theory behind. Not that they said it the way they said it. Make sense? So the theory tells you whether the test is one-sided, two-sided. The rest I talk about are just tricks to identify it. To identify the theory behind it. Okay, the last one. If a hypothesis is rejected at 1%, what would be the chance of committing top one error? Someone told you you reject at 1%. Someone else is asking you, give me the chance of committing top one error. What would be your answer? Anyone? What is the chance of committing top one error? That's the p-value. So the question tells you what would be the p-value if you reject at 1%. That's what the question is telling you, right? If you reject at 1%, what's the p-value? It would be less than 1%. That's it. If someone told you reject at 1%, the p-value must have been less than 1%, but you don't know exactly how much. It might be 0.5%, it might be 0.25%. You don't know. Right? The only thing you know is the p-value, which is the actual probability of committing top one error, must be less than 1%. But you don't know exactly how much. Right? This one on a test. This one, I put 1%, 2%, less than 1%. Most people answer this one. Right? If you reject at 1%, the probability of committing top one error is not 1%, it's less than 1%. 1% is the maximum probability of committing top one error. Right? Don't mix them up. Alpha is the maximum, the actual, the p-value. So this was telling you the alpha is 1%, what's the actual? It will be less. Make sense? Okay, that is this one. Next one. The calculated confidence interval for the population mean falls within this range. That's a 98% confidence interval. What would be the correct statement based on that confidence interval? Is the first one correct? 98% of the individuals in the sample have a height between this range. Why not? The confidence interval is about this one, not this one. You use the sample mean to conclude about the population mean. So it's not about the sample mean anymore, it's the population mean. That is telling you 98% within the sample form, not within that range, which is not true. It's about the population mean. Right? You're saying this is within this range. That makes this one wrong. You're not talking about the sample, you're talking about the population. You're using the sample to talk about the population. So it's not about the sample anymore. That makes the first one incorrect. What about the second one? Is the second one correct or false? If we repeat our sampling 1,000 times, 980 of the sample means will fall within this range. True or false? That is false for the same reason the first one was false. It's an inference about the population mean, not about the sample mean. That makes the second one wrong. For the same reason the first one was wrong. What about the third one? That's what the confidence interval means. If you repeat the exercise 1,000 times, you're going to get 1,000 different ranges. 98% will include the actual population mean. That is the reason you're 98% confident your population mean falls within this range. So you think this is one of the good samples. This is one of the non-80, not the bad ones. Next one, that is the meaning of confidence interval. Right? It runs from the sample to the population. But about the population, not about the sample anymore. 2% of the individual in the state, again, you're talking about the sample. It's not about the sample, it's about the population, from the sample to the population. That makes this one incorrect. It's about the population mean, but you take the sample and conclude from it. Okay, next one. A researcher tested a hypothesis about the population mean, found the p-value to be 6.2%. Okay. Based on that, which of these are correct? The 95% confidence interval will include the population mean as stated in the norm. True or false? I'll give you a simple rule of thumb. Get this. How much is it? How much is it? Right? Any confidence level higher than this, you should fall inside or outside. Any confidence interval, confidence level, I should say, higher than this, should you fall inside or outside? Any confidence interval, confidence level higher than this, will be an alpha lower than 6.2%. You should not reject. So you should fall inside, not reject. You should fall inside. Anything less, you should fall outside. Simple idea. Since the p-value is 6.2%, you should not reject for any alpha less. That means any confidence level higher than this, you should fall inside, not to reject. Makes sense? So get the p-value, subtract from 1. Any confidence level higher than that, you should fall inside, not to reject. That's what I wrote. Anything less, you should reject because that corresponds to an alpha higher than the p-value. Make sense? If simple rule of thumb, follow it, you should be able to answer any question like this. If that didn't work, if you don't know the rule of thumb, then you should basically check each one individually. That takes time. You should there say 95%, that's 5%. Should I reject at 5%? No, because the p-value is 6.2. Since you don't reject, you should fall inside and continue with that all the time. That takes time. Use the rule of thumb. Let's simplify a question like this. Get 1 minus p-value. Any confidence level higher, you should fall inside because you should not reject. Anything lower, you should fall outside because you should reject. So in this case, you should fall inside all those because they all will give you an alpha less than 6.2%, and you can fall inside that range because you should not reject an alpha lower than 6.2%. Make sense? This corresponds to 5, 4, 1, 2. You should not reject any one of those alphas, as it does should fall. Make sense? Anyway, use the rule of thumb. 1 minus p-value. I wrote it here. 1 minus p-value. Get the confidence level. Anything more than that, inside. Anything lower than that, outside, because you should not reject. You should reject. Based on the p-value given. Right, so 1 minus p-value, get the confidence level. Anything more inside, you should not reject. Anything less outside, you should reject. Right? Let's simplify the whole thing. Otherwise, you have to look at them individually if you don't know the rule of thumb. You have to go and say, let me check this one. That corresponds to 1%. Should I reject at 1%? I shouldn't because the p-value is 6.2%. Since I shouldn't reject at 1%, the null should fall within that range, and so forth. You should then check them individually. That takes time. Right? Make sense? Okay. Anyway, that is a nice question. Historically, has been on test 1. Somehow, all these conceptual questions don't average very high, right? There's a rule of thumb for everything, but if you don't know the rule of thumb, you're still working with the p-value versus alpha concept, right? P-value more, you don't reject, p-value less, you reject, and that's the idea. Next one, still conceptual. You're doing a medical test for blood glucose. Anything more than 58 is high blood glucose. What's the null of the alternative in that test? When you go for a blood glucose test, what's the null of the alternative? Yep.
The null is if it's equal to 58 and
The null is,
equal to 58.
or you can put the plus 2, but normally we put the 58 only. You can ignore the sign. The alternative is,
Greater than 58.
so basically you say he has high blood glucose, that's the alternative. Then I'll say he doesn't. Right? Then no, he doesn't have high blood glucose. The alternative he has. Right? So what's the top 1 error in that case? What's the top 1? You reject the null. If the null is right. That's the top 1. What's the top 2? You don't reject the null. If the alternative is correct. That's the top 2. What's the confidence in that test? Complement of type 1 is a confidence. What's the complement of type 1? don't reject the null, and you're right. That's the correct decision. That's complex. What about the power? You conclude the alternative, and the alternative is correct. These are correct decisions. The other two are errors. Top one, top two, these are correct decisions. Make sense? So based on that, we know this is incorrect. What about the first one? Type 1 is to conclude that the individual has high blood glucose. Is that correct? The first one? That looks fine. That looks correct. To conclude the high blood glucose, when it does not. That's correct. That's an error, type 1. Right? So the first one is correct. What about type 2? It says to conclude that the individual has high blood glucose when he has. That is not the error. That's a correct decision. That's actually the power that goes. That's incorrect. That's not an error, right? The condition is fine. The decision is not an error. Right? The condition is fine without the error, but the decision is correct decision here, not the wrong decision. So it's not an error, right? The correct decision. Anyway, so be careful. Question like this, you probably have to set it up and fund it. If you just want to use your imagination, often you get it wrong. So you have 4 cases in some of them. Right? Yeah.
So for type 1, not the error, but the correct one, for confidence, we know what confidence is, but for...
See, when I say complement,
Yeah.
the probability of this one, the complement is the complement. So I should say probability. The probability of this one, we call it p-value. The probability of this one, we call it confidence. Right? The probability of this one, we call it beta. The probability of this one, we call it power. So I shouldn't call it just power. The probability is called power. Yeah.
What's, like, we do stuff with the concept of confidence, will we do something with power? Because power...
These are interrelated. They're not complement. You can see they're not.
Yeah.
But if you increase this one, you decrease this one. You increase this one. If you want to have a test with a higher power, one way to do it is to increase top one error. But top one error is an error. How do you want to increase one to increase the other one? That doesn't make sense. You will see later on there's a way to do it without increasing one. But they're interrelated. There's a negative relation between these two. One goes up, one goes down. Right? You want to have a test that gives you good confidence and good power. You want this high and this high. Alright? How do you achieve it when there's a negative relation between these two? Everything equal. Later on you will see you achieve it by increasing sample size. Right? If you keep this constant, alpha constant, you can decrease the beta, increase the power by increasing sample size. That's what the real world researchers do. They basically work with a sample size to achieve what they want. We'll have that next week. The trade-off between these two shot next session. Anyway, so up to this point you don't really know the other side of it. Until then you have solved half of the test. Okay, calculation. The average length of stay of travelers to Vancouver has been 8 days. The pandemic is believed to have reduced that. So based on your reading, is it upper tail, lower tail, two-sided? Two-sided, we call it direction, less test, because if you read it, you don't see more, less, at least, at most, none of those, right? This is clearly there is a direction to it, because you see, reduced, that's the direction, right? So obviously not two-sided. If you doubt between upper and lower tail, check the evidence. Check this one. That should be for the alternative, right? We are testing 7, testing 8. This evidence does not allow you to do upper tail test. This is clearly lower tail test because the evidence does not allow for upper tail test at all. Right? So one way to trick the question is check the evidence. in a task with a direction is for the alternative. That's the evidence for the alternative. Muscular tail test, the null says otherwise. And now I have X bar that should allow me to reject the null, whether I do or not depends, but there is no evidence for it. Do I have the population standard deviation? Do I have sigma or no? Or I don't? You read it. Do you see sigma there? There's a standard deviation here. Is it population or the sample? That's S. So I've seen people trying to figure out what sample is. And they need to see sample standard deviation. Often you don't see it. You see it says we took a sample. That's the mean, that's the standard deviation. Obviously that's the standard deviation for the sample, not for the population. Right? If this was a photo population, it would have been before the sample mentioned. It would be way before this one. It would be somewhere there in the first sentence. Right? We're drawing from a population with this standard deviation, which is in the case. This is as, so in step number 2, we need to calculate is that. What is n? What is n? 41. Degrees of freedom is 40, that is R. T stat, how much is it? How much is T stat?
Should it be root 40 or root 41?
41. What is our T stat?